Welcome everyone. Welcome to a new Teesing webinar. Today we're going to discuss micro turbine technology in low flow applications. My name is Bob Asselman. I'm a sales engineer for flow applications at Teesing. And today I'm together with Samuel from Digmesa. Would you like to introduce yourself?
Sure. I'm a key account manager at Digmesa. My name is Samuel. And I support Teesing in case of measure flow. That's what we talk about. Digmesa is focused in flow measuring.
Okay, thanks. And welcome. Welcome to our viewers. Today we would like to discuss first an introduction to the turbine wheel measurement technique. So we're going to talk a bit about how this measuring principle works. For this kind of flow meters, we typically use pulse signals. So we will explain a bit about that. And after we've discussed the flow meter technique, we will introduce you to the Digmesa Nano flow meter family and its key features. These meters are produced automatically, and we'll show you a bit about that. And the most important part is the applications where we can use these kinds of flow meters, because in the end we have an application where we try to find a suitable flow meter solution. So we will zoom in on what typical applications we can use these products for. So what is the turbine wheel technique? Here we see a Pelton wheel, which is already quite an old phenomenon, where you have a eccentric placed turbine wheel with pedals, and you have a stream, and part of the energy from the stream is converted to kinetic energy that makes the turbine rotate. To convert this rotation into flow meter signal, we use pulse signals. We will look into that a bit more. And this technique uses a combination of Hall sensors and magnets, and we're going to elaborate a bit more about that as well. So here you have a typical overview of what a flow meter looks like. So water enters from this side, and the kinetic energy is converted into rotation of the Pelton wheel. And the Pelton wheel has some magnets in it. We place a Hall sensor above, and as the flow increases, the rotation speed of the Pelton wheel increases as well, and this is proportional to how much flow is running through the flow meter. Here we see a typical cutout of a Digmesa flow meter, which is based on this Pelton wheel technique, turbine technique. Water enters from this side. Here we see a nozzle, and we have different nozzle sizes, and the nozzle size determines how much flow is going to pass through the flow meter. So it limits the upper and lower range of the flow meter to make sure that the flow that's running through the system has a linear output. So every liter has a constant amount of pulses. So we have a constant pulse rate coming from the flow meter. We see the turbine over here with magnets integrated in the axis, and these magnets will help us to convert the signal to something we can use. To be able to convert the signal, we use a Hall sensor, and a Hall sensor is a device that is able to detect a magnetic field. So we have the axis which is rotating as the turbine is spinning, and the magnets come across the Hall sensor, and every time the magnet influences the Hall sensor, a small voltage is generated in the form of a pulse. Here we have an overview of different turbines. So in the upper part we see a pulse signal coming from a turbine with two magnets. So every half of a rotation, a magnet comes across the Hall sensor and generates this higher peak in the signal. Then it drops down to a lower level, and the next magnet comes across the Hall sensor, and we create the next peak. We are able to play a bit with this by adding more magnets to the sensor. And in the lower graph, you see the same turbine with 4 magnets inside. So now every quarter of a rotation, the magnet passes the Hall sensor, and this helps us to increase the amount of pulses per unit of volume. And especially when we have dosing application where you want to have an accurate dosing of a small quantity, adding more magnets can help increase resolution. So instead of 100 pulses, we have thousands of pulses per liter of volume. So this is a brief overview of how this measurement technique works. And in the Digmesa Nano sensors, we actually use this measurement technique. So Samuel, would you like to introduce us in this flowmeter series?
Sure. To give you a break a little bit of the talking. Thank you for the explanation. So as you can note, Turbine Technology is not that complicated, but let's show how we have driven this Turbine Technology to perfection. We have on this side our nano brass. Brass as a material means we have temperature and we have pressure resistance. Pressure, we talk about 20 bar, and temperature, we talk about 100, not bar, 100 degrees. We have the same nanotechnology in the middle, just with inox as a material, which means if you talk about chemical resistance, aggressive medium, like an acid or something else, then we can use this material. And the last one, we have our nano in plastic, which means low pressure and low temperature applications. We talk more about some application examples a little bit later, but here we can say mostly use for this device is on the low pressure side before a pump, and the suction side without temperature.
Okay, so we can choose from different materials, same kind of flow meter, but depending on the application, either pressure or temperature, we switch to a metal version. And for chemical resistance, we can either use a plastic version or stainless steel.
Exactly.
Okay.
If you take a look a little bit more, how does it look inside? Still here you have the flow is coming in, the turbine is turning, flow is going out. Our nano in plastic, there we have a tube. Inside we have a cage with the turbine. Then we have this rack for the electronic, and we have again a Hall sensor and a connector. If we go from the low pressure, low temperature version to the nano brass temperature and pressure version, you can see we have also some different opportunities in the connecting. So depend the customer, we already can complete the flow meter with the cable and the connector. And still again, flow comes in, turbine turns, flow goes out. And here a really important advantage from this nano is just imagine the little small turbine is turning a lot. And that means we have a lot of pulses. So you're talking about the magnets, 2 magnets, 4 magnets, a few hundreds or a few thousands. Here we can go up until 48,000 pulses
per liter
minute. Exactly.
Okay.
And this is going massively. This is really a device. If you want to have an exact dosing, this is a big advantage.
Okay. I noticed you can also supply them with a pulse divider. Can you explain about that?
Exactly. Sometimes you have an electronic who is just still not able to handle this many pulses. So then we are able to provide a pulse divider where you can go down again for a few thousand pulses instead 48 or 40,000 pulses.
Okay, so if you need the high resolution for the exact dosing and your electronics can handle a higher frequency, then you can use the normal version. But if your electronics need a lower frequency to detect the difference between pulses, then we can use the pulse divider.
Exactly, and this need we figure out together with the customer in a conversation.
Okay, thanks. Yeah, to summarize some key features of this Nano series, I think it's a unique design. It's very small. We will show it later in this video in real life on camera to see how small it actually is. One of the other benefits we should mention is the flexible mounting position, especially for OEM customers. Space is most of the times an issue. You have limited space to fit all the components. And with this kind of flow meter, you're quite flexible. It doesn't have to be exactly vertical or horizontal. You can fit it in any position you'd like, or wherever you have some room in your system. So that really helps to build a compact solution. And as we already mentioned, high pulse rates, but also options with a pulse divider. And this product is produced fully automatic.
Some products are produced fully automatic, for example, the Nano in plastic. And we are really proud at Digmesa that we have a new building where we have included like a centralization with our own injection molding company.
Okay.
And if it's possible, Bob, to show a video, we can provide you some pictures, some moving pictures from our automation.
Let's see if it's possible.
Perfect. So here you can see our robot. This robot is moving around the whole company, so be careful when you walk around. And the idea behind this is a 24/7 production. So sometimes you have to set some new, and here we are able to change this. So that means the box is full. There, he take a note, he take the box, and then he's going back to the warehouse, put in the fully box, and take a new empty box. He's going back to the machine, and the machine can produce and produce.
Okay, thanks for sharing us. It looks quite impressive, actually. Good to know that the flow meters are built in separate modules. So we have a lower part, an upper part, and an electronic part where we can make quite some combinations fitting any application. And talking about applications, here we see the Nano Inox, so the stainless steel version of the Nano family, which is quite good to use for typical low flow applications. But it's also capable of resisting pressure and higher temperature, combined with a chemical resistant material. So it's typically used in medical or dosing applications where you can have a bit of an aggressive acid or a not so nice to handle medium. And especially where you need a very high dosing accuracy and high repeatability, because every dosing should be equal to the one you did before, especially in a medical device. That's quite important. And there you see that the Nano Inox can be a very nice solution to cover all these specifications.
And it's also actually an important device because let's say the pump is quite stupid. So the pump is just moving the flow and you need to know, is there flow or is there no flow? So let's talk about redundant. You have to control if it works.
Yeah, exactly. You see more and more requirements to verify and measure actually what you're doing in applications like this. So in this case, quite a nice solution. We already mentioned coffee earlier in this webinar. Can you elaborate a bit on these kinds of applications?
The most important machine in the world since the pandemic, I think. We at Digmesa, we talk about two different coffee machines. We talk about professional coffee machines, where coffee machines in restaurants and bars connect direct into the water line. So you need some pressure and temperature resistance. So there you can use a typical use for the nano brass, and a typical use for the nano in plastic is a household coffee machine, where you just wanna, you buy some beans and you wanna have the same coffee in the same quality and the same quantity every day. So for there you can use our nano in plastic, where we have a big advantage, because especially in this kind of machines, we talk about space. Space is a really important thing. And maybe you already told us that. We can show the product a little bit closer.
Yeah, I can switch to this camera.
Here you can see this is our nano compared to our nano in brass. So these devices are really, really small. So you don't need space. You can install it flexible however you want, and you have a high precision.
Okay, nice to seeing them in real life, so to say. Sometimes we have applications that are not so much on the very low flow side. We see more and more customers that want to measure very low flow applications. So that's why we try to focus on the nano applications today. But we see a lot of different applications. Every flow application is different, and that's why we always say let's start from an application, discuss the specifications for a typical system, and try to find a suitable flow meter solution starting from there. So we can not only do something with very low flow, but I know that you are also developing a flow meter that is based on the nano design, but can go up to 6 liters a minute, so to cover a bit higher flow ranges. Can you show that flow meter as well?
Sure, if you can switch to the bigger camera again, you can our nano flex, and flex is a pretty good word for the description of Digmesa. So the nano technology and the flexibility of the nano is pretty good, and we had some customers, they asked us, they want to integrate something in the system, in a filter head for something, and they need a higher flow. So Digmesa said, okay, let's take our nano technology and go ahead for higher flow. And this is a concept study where it's showing us that we are able to go into an application together with a customer. So he's giving us his idea, and we work together with him to make an integration.
Okay, interesting. Thanks for showing. So that's a typical example of a solution for a higher flow application. The benefits of the turbine technology is that it works quite properly for low viscosity medium, like a water-like medium. But if viscosity goes up, then it influences the measurement. So for different kinds of application, we also have to switch to different kinds of measuring techniques. And one example we can show is we also can provide a oval gear type flow meter, which is more suitable for higher viscosity product. And as we already mentioned, because you have your own molding facility, we can use a lot of different materials. So if you need more or less chemical resistance, we can just switch to a different material. You already named a few examples. Can you name some more examples of materials you'll be able to produce?
Sure, I try to be short because we have thousands of opportunities and we do not have enough time, but we already talked about the modular production flow meter on site. So that means we have lower parts, upper part, and an inside life. Mm-hmm. And that means we have different material. We have in housing, we have a large and Arnite PVDF. We have an inside life with some PVDF turbines as well. We have different O-rings like EPDM, Viton, Colorex, etc., etc. We have different electrical connections. We also can measure conductivity and temperature. Bob said we can also measure viscosity mediums, etc., etc., etc. And last but not least, if we have some requests from customers, we can customize, or even we can produce something new, develop something new. 10% of the people from the Digmesa employer are in the engineering and development. So this gives us many, many opportunities.
Okay, and it always keeps our lives interesting. So if you have a challenging application, a different application, always feel free to contact us, and we can look from the application and see if we can come up with an interesting solution.
Also paperwork.
Paperwork, yeah, we're not afraid of a bit of paperwork. We see a lot more and more demands for certification, MDR regulations, more and more new norms and certificates are coming up, and yeah, most of these certificates I think we will be able to implement. And as we come to the final part of this webinar, we would like to ask you if you have any questions you would like us to answer right away. Otherwise, we also will be able to answer questions after the webinar. Maybe you already contacted Rogier in the chat. Maybe he has already answered a few questions. But if there are some questions that are still open, then please feel free to put them into Slido right away, and we try our very best to come up with an answer.
Also, if you have maybe some questions from the last side, if there are other opportunities, we are pleased to get your feedback, maybe for a next webinar for the topic, if there are some interesting. So just let us know.
There was one question from the audience.
Okay.
If you're able to tell something about the pressure ranges, specifically from Digmesa and specifically from this technique in general.
Okay. Not sure if the question was good enough to hear from the audience, so I'll repeat the question. The question that Rogier asked was, what is the pressure and temperature range for this kind of project and for the turbine technique in general? Maybe you can say something about the limits of the products from Digmesa.
Yeah, we actually have some standard limits, 20 bars. So this is something you shouldn't go more. So normally 10, 15, 16 bar, it's not a problem. It's not, the German word is Bestdruck. So don't be afraid if you go up until 17 bars, there are still only 3 bars left. That's not a problem, but more than 20 bars could be difficult.
Okay. And from a broader perspective, I know from in the market we have flow meters available that go up to 100 or more bars. Also in turbine technology, but then we're talking more about industrial applications, and in industrial applications we switch over to a different kind of turbine meter. We go to flanged bodies with a higher pressure rating. We can go up to 100 bar or even more, but that's not applicable for these kinds of sensors. But as I already mentioned, we always start from the application and we try to find a fitting solution for the application. So if you have a high pressure application, then feel free to contact us with some specifications, with some information on what you try to achieve, and can look into that as well. I think there's also a question on the screen. What happens to the pulse signal if flow is reversed? If flow is reversed, the turbine will start turning the other way around, and that still causes the magnets to pass the Hall sensor, and in that case you still get a pulse signal. I'm not sure if it's that linear if you put it the other way around, but it will generate pulses. So if it's a problem, then I think you should look into installing a check valve to make sure the flow is not able to move the other way around. And if you specifically look for a flow meter that is capable of a bidirectional measurement, then I think we should look into that in more detail. But correct me if I'm wrong, the turbine will start turning the other way around, right?
Yeah, you can generate pulses in every way. We at Digmesa, we say always you need a stable closed system. This means also air is not good. We have some foam detection for sure, but if you have air in the system, you can generate repeatable pulses. Yeah. So you need really a stable closed system with stable pressure, and then it works.
Okay. But also in this case, if you're looking specifically for a bidirectional flow measurement, feel free to share some information with us, and we will be happy to look into it, I think. Another question that came up is, I have to read it from the screen. Just out of interest, do you have any experience with energy harvesting applications, micro generators using your turbine technology? I have not. I'm not sure if you have any experience with this.
Me neither.
Okay, but I'm curious. So if you, basically the same answer. If you could share your thoughts or your specifications or what you're trying to develop or what you're working on, then we can look into it and see if we can be of any service. So then I would like to switch to this side, and thank you all for watching. Thanks for joining us today. Thanks for your input. If any questions come up later, or if you have an application that you want us to think about with you, please feel free to contact us. Our contact details are on this slide. Just let us know. I think for now this is the end of the webinar. On the next slide, you'll be able to give any suggestions for topics on additional webinars, any feedback on what we did today. Feel free to leave any comment, and we'll see you next time. So thanks Samuel for joining us, and thanks everyone that watched today.